Hello everyone, today we will talk about the Tarapur Atomic Power Station or known as TAPS. TAPS is located in the state of Maharashtra in India and it is the first commercial nuclear power station built in India. For your information, in India, nuclear power is the fourth largest sources of electricity after thermal, hydroelectricity and renewable sources of electricity. The construction of taps began in 1962 and after years in 1969 it went operational. The total capacity of this power plant is 1,400 megawatt with initially there are two boiling water reactors with 160 megawatt. Then in the 20s, two more pressurized heavy water reactor which has 550 megawatt was constructed. Unfortunately, after decades of operation, TAPS faced several mechanical and technical errors at their reactor system. The most significant cases reported in 1995 where there was a leaking at the waste immobilization plant. After some inspection, one of the steam pipe was leaking and the leaking radioactive wastewater contains cesium-137. The radioactive wastewater entered the train water system at nearest village. This incident resulted in some environmental issue when some villagers reported that their herd animal died. Not only that, there are other cases occurs also such as overheating. For instance, in 2013, the extreme temperature of acid nitric led to a leakage in the reactor system.
Because of the incident that occurred in Tarapur, India, NRC or Nuclear Regulatory Commission has introduced a way which called buried piping. So what is buried piping? Buried piping is where the pipe is buried under the ground to prevent the radiation to spread in the atmosphere. But the procedure is very difficult and the technician have to do it correctly to make sure that if the leak is still happen, the leak is not exceed the limit of radioactive material release and not exceed the limit of public radiation doses. Next, the company can also take the initiative to install the monitoring system to assist in finding the source of the leakage during the reactor operation. This monitoring system is like a sensor, and how it works like a gold detector. When we use the gold detector, when we close to the gold, the detector will give you a signal in a form of sound. And this is similar like this monitoring system. If any compartment or any instrument that close to the leakage, it will respond to this sensor and give you the information so you can fix the problem earlier. Other than that, the most important thing is the company should take note about the monitoring system performance such as first, overall response times, second, the detector accuracy and sensitivity, and lastly, ability to detect the leakage at any temperature, humidity and radiation level. This is so important so that the monitoring system is capable in detecting the leakage. Lastly, the company can also install the crack growth monitoring system. This is also important because we don't want the crack grows and propagate and lead to the metal failure and lastly lead to the leakage again.
Hi guys, for my part, I will introduce to you about the recommendation or the strategy that we can do to avoid the disaster or accident related to the Tarapur reactor. So I will propose two recommendations. The first recommendation is a short-term recommendation. It can be completed within the 2 months period. So the first strategy that I will like to share is we need to prepare the full guidelines for severe natural disaster, and we need also to review back all the existing emergency operating procedure. So in the Tarapur reactor, always occurring the severe natural events, for example tsunami, earthquake. So from the event, it can lead to the reactor problem, for example leakage, malfunctioning tube. So when the pipe leakage or the tube is malfunctioning, so the effluent from the industry, for example the radioactive, can be exposed to the air, so it will be harmful especially for the environment. Okay, so the second one, what we need to do is we need to have the regular training on the emergency operating procedure, and also we need to have the disaster management training for all the workers at the multiple plant site. So all the all single workers in every single plant site need to have the disaster management training for them to be ready if the disaster occur. Okay, and the second recommendation is related to the long-term recommendation. So the first strategy is we need to have the provision of injecting coolant into the reactor. So as we know, the reactor is operating the boiling water reactor that use water to generate electricity. So somehow the reactor can have very high temperature and exceed the desired temperature. So by injecting the coolant, it can reduce the temperature back into the normal temperature. So for example, we can inject the fresh water into the dry well and also use the suspension pool. The second long-term recommendation is we need to ensure that the core cooling measure is well functioning. Okay, we need to have the emergency core cooling system well functioning. So as you can see in the picture, that is the boiling water reactor diagram. So we need to mention that all the system, especially the cooling system, is well functioning. Okay, so we also can have the provision of water resources. So why we need the water sources or water resources? Because the water is used for the coolant system. We can have the underground raw water tank if the water is not sufficient, and also we can have alarm so that it can notice us when the temperature arise above the desired temperature. Okay, and the third one is we need to maintain the reactor pressure vessel and also maintain the containment pressure below the design pressure, because somehow the reactor can operating at very high pressure. So by depressurization the reactor, we can reduce the disaster or accident that related to the Tarapur reactor. And the last one that I want to share is we need at the plant site, we need to have the availability of the fire tenders at the plant site. So why we need the fire tenders? The reason is for the safety purpose. So example of fire tenders, we can have the fire engine, the fire truck, so that everyone, especially workers in the Tarapur reactor, will be safe. So I think that's all from my parts. Thank you.